Welcome to section 4.2, solving by substitution. Now in this section, we're not going to be doing any graphing. Graphing was just there to show you the meaning of what it is to have two lines crossing, intersecting, and having that point be the solution to the system. Now, there's two techniques. There's the substitution techniques, which is we're going to concentrate on in this section, and then there's an elimination technique, which is section 4.3. We're going to concentrate on the substitution, and the idea behind substitution is you have two equations. First off, you start off with two equations. One of the equations has to be of the form where you have a variable equal to something. So let me take this first equation. This first equation is not what I said it should be. This is not a variable equal to something. The second equation is a variable equal to something, where it doesn't matter whether it's x or y, it's equal to something. In this case, y is equal to x plus 3. So what we're going to do to solve it is we're saying, well, y is equal to this bundle. Why don't I take what y is supposed to be and substitute it into the other equation? Okay, and then what we do when we have that substitution is we have x plus, and you really should include the parentheses when you do the substitution, but in this case it doesn't really matter because y is not multiplied by anything, so I'm just going to leave it without the parentheses. Okay, and now this equation we can certainly solve, okay, because we have 2x plus 3 equals 9, and then I'm going to subtract 3 from both sides to get a 6 on the right, and then if we divide by 2, I get x is 3. So what they're saying here is these two lines will cross, and they'll cross when its x coordinate is 3, but it's not enough to know that when it occurs at x equals 3, we need a point, and a point is always an x and a y. What you do to get so far, here's what we've got. We've got the point is x is 3, and we don't know what y is just yet, but we can certainly figure out what y is by taking this x, which we know to be 3, plugging it into there. 3 plus 3 is 6, so y equals 6, and that's the point. That's the point where those two lines will intersect and be the solution to the problem. So let's put that in there, see if we're right. 3 comma 6. Okay, we can use this little template right there. Oop, I screwed up. Let's start over again. Put that there. 3 comma 6, and check your answer. There you go. That's it. That's substitution in a nutshell. Now what we're looking for here, let's write these equations. Y equals negative 4x. These are lines. I mean, you can graph them, but there's no real need to graph them, because actually graphing is not that much fun. When you have an easy way like this to solve for it, I would use the algebraic way to do this. Do we have a variable equal to something? We certainly do. Pick one. Y equals something, y equals something. Okay, I'm going to pick this guy here. Y equals this bundle. I'm going to take that bundle, substitute it into the other equation, okay, and when I make that substitution, I have minus x minus 7, no need for the parentheses because y doesn't have any variable in front of it or number in front of it, negative 4x minus 25, and now we could solve this. We could certainly solve this. What we can do is let's add 4x to both sides. 4x here. See, I just do the opposite. Add 4x to both sides. This is the basics of Algebra 1. The equation tells you what to do. You do the opposite. This is 3x minus 7 equals, now the whole idea was to cancel that. We get minus 25. And then we're going to add 7 to both sides. So we're going to add 7 to both sides. Adding 7 would cancel out this -7. And when I add 7 to -25, I get -18. And when I divide by 3, I'm doing the opposite. See, x is being multiplied by 3. I divide by 3. I get -6. So here's what we got for a point so far. -6 is the x value. And the y value, what's the y value? Pick an equation, any equation. But in this case, I'm going to pick this one because I think it takes less work to calculate what the corresponding y is supposed to be equal to this. If I plug in -6 for x, okay, a -6 is 6 minus 7. 6 minus 7 is -1. There's the answer. That should be the answer right there. Okay. Parentheses, -6, comma, -1. Close those parentheses, hit enter. Very good. 2 out of 11 done. Let's try the next one. Okay. See, I don't want you to keep thinking that you always have to have a y equals. The last 2 problems had a y equals. It doesn't matter what variable you have. As long as you have a variable equal to something, then you could do substitution. So let's do a file, new sheet of paper, get it ready. Okay, let's write the equations down. We got -x minus y equals -4. Negatives all over the place. X equals 3. That's a -3y. -3y right there. And we're saying, okay, do we have a variable equal to something? Yes, we do. X is supposed to equal -3y. So what I'm going to do is put some parentheses around here. And what I'm going to do is in the top equation, wherever you see an x, I'm going to substitute in the opposite equation the -3y. Now let's figure out what we have here. This is a minus. Now here we do need the parentheses because what we're substituting is a -3y. Okay, minus y equals -4. See, when you do the substitution, you should get an equation with one variable. Double negatives. Negative is positive. And -3y minus y is 2y equals -4. I just combine my like terms, and if I divide by 2, I get y equals -2. So you're going to intersect. Those lines are going to intersect at a y value of -2, but we need the x value. So here's what I'm going to do. I'm going to show you what we have so far. Y is -2. Remember, it's xy. -2 is the y. How do I get the x? Come over here. Plug it right into there. Okay, x is equal to -3 times -2. -3 times -2 is 6. There you go. So far, we're getting answers. It's never going to work out that way all the time, but we're getting answers. This is -2. Because remember, there's also these other types of answers here, okay, where there's no solution or infinite many. We're going to show you how that works out in a second, okay. Right, okay, now here's what they're saying here. Solve by substitution and check, okay. Well, we can check, but I'm just going to solve by substitution here. So far, I'm looking at these equations. I do not have a variable equal to something. Not a big whoop. Pick an equation, any equation. Solve for a variable. I'll solve for x, this bottom equation. I didn't touch the first equation because that looks too complicated. Because there's too many terms there, and, you know, that's the only reason. It just looks more complicated. The numbers are big. But this first equation, x plus y equals 0, is not conducive to a substitution because there's no variable equal to something. So I'm going to pick x equals. Subtract y from both sides. That will get rid of the y from the left. and you'll effectively have that. X is equal to negative y. Now what you're going to do is substitute this negative y into the other equation for everywhere you see an x. Okay, so I have a negative, and make sure you put it in parentheses to indicate that what you're doing is substituting that expression into the variable. Plus 17y equals 36. Okay, double negatives, y plus 17, y equals 36. 18y, collecting my like terms, equals 36. And divide by 2 is 2. Okay, so what we've got so far is the number 2 for y. Now, what's x? Here, we got a nice equation right over here. Pick the simple. I mean, I suppose I could plug in 2 for y up here, but why do all this work and solve for x? Here, x is equal to negative y. Y is 2. X is negative y. Negative 2. Nice. Let's plug that right in there. Very good. Now, they say check. Basically, what they're saying is, before you hit, check your answer, plug in negative 2 for x, 2 for y in both equations. They should both work out. You should generate a 36 here in the top equation. And certainly negative 2 plus 2 is going to give you 0 in the bottom equation. So I'm confident that that was correct. Okay, let's take a look at this guy. This guy. Okay, let's try this one. This one looks complicated. Well, maybe not so complicated. File new. Okay. And, geez, this doesn't look good to me. I need a variable equal to something. Well, I think if I look at the bottom equation, I have a plain, beautiful y by itself. I don't want that negative 4x even there. So if I added 4x to both sides, what I would get on the bottom equation is a y equals the 4x, the 4x cancels the negative 4x on the left, but the 4x survives on the right as a positive, plus 39. Okay, so that's the bottom equation. I solved for y because that looked most convenient. And this is now ready for substitution. Okay, what I'm going to do is take the other equation, jot it down. Now, y is equal to this bundle. Take that bundle and substitute it in for y in the other equation. 2x. Now here you need the parentheses. So when I substitute, for sure, there's no if, ands, or buts. You need to have the parentheses because there's a 6 in front of the y that says you're going to multiply y by 6. You're going to multiply the bundle by 6. So leave it there. Now we've got some big numbers to work with here, so let's get rid of the parentheses. Let's get rid of the parentheses. So we need to multiply through the parentheses by 6. So 2x is what it is, plus 24x plus 39 times 6. So 39 times 6 is 234. Equals 26. And so we're going to combine these like terms to be 26x plus 234 equals 26. Let's subtract 234 from both sides. I get this, 26x equals 208. And I bet you 26 divides evenly into 206. It doesn't necessarily have to, but they like to give you answers that are whole numbers. So if I divide by 26, I get the number 8. And the fact that you come up with a real number means that these lines, if you were to graph those, they would cross. They would cross at an x-coordinate of 8. but that's just half the answer. 8. What you need to do to get the y is come back up here, take that y, plug it into there, because y equals this mess, so plug in the 8. 8 plus 39. And what do we got there? That's going to be 32 plus 39, which looks like it might be 71. 71, that's kind of a big number. Let me make sure that this works. If I did make a mistake here. X, no, that's it. It is what it is. It is what it is. So I'm going to come over here and say 8, comma 71, close it, enter. Okay, I knew I did something wrong here because that 71 was just too big. Now, why is that wrong here? Okay, we got the 8, 26. Oh, you know why? Duh. Minus, we subtract 234. When we subtract 234, you get a negative 208. This is a negative 8. So that should be a negative 8. Okay, so let's take a little eraser and erase all this stuff. That 71 looked too big. Looked too big for the problems that we had here. So I'm going to erase all this stuff here as best I can with this stupid little brush. Okay, so now here's what we're going to do. We're going to say 4 times negative 8 plus 39. This is negative 32 plus 39 is equal to 7. Now that's a more reasonable number for the kind of problems that we get. So let's erase that 70. Let's erase that 1. And there's your answer. Okay. How about if we get rid of that 71 and make it 7 and make the first number negative 8? That's fantastic. Well, you know, getting things wrong is a learning experience. Okay, let it be a learning experience. It makes us stronger. It makes us stronger in the end. Okay, now let's take a look at this problem here. So far, I'm just doing the same thing over and over. I'm going to tell you, from my experience with doing these type of problems, that this is going to be a strange case. Okay, so I'm going to look at this problem and say, well, it's you being a student, you might not recognize it, and that's okay. That's all right. All you know is what I showed you is, take an equation equals 6. And now this equation right over here, I need a variable equal to something in order for me to substitute that something. So this looks like a nice equation to use because I can solve for x by simply subtracting 7y. So what I have here is x equals, I subtract 7y, minus 7y here, minus 7y here is minus 7y plus 3. Okay. Okay, now strange or not, I'm going to take that bundle, which x is supposed to be. X is supposed to be this bundle. So in the top equation, I go to where the x is. I substitute that bundle in for x. 2 times a negative 7y plus 3 plus 14y equals 6. Okay, nice. Now multiply through the parentheses, negative 14y plus 6 plus 14y equals 6. Clean up your y's. Negative 14y gets rid of the variable. There's no more variables. And when there's no more variables, you have an oddball case. Okay, you can't solve for x, you can't solve for y because the variable's gone. We did everything correct. Now, what do you do in this situation? It cannot be a. You can only get a if you still have a variable and that variable equals something. When you have something that's certainly true, this is certainly true, and it doesn't matter what you plug in for x and y, this will always be true, That's infinitely many solutions. That's what that means. When you do all your math and you generate something that's true, and it doesn't matter what you plug in for x and y, it'll always be, it'll come out true. There you go. It's infinitely many solutions. Well done. And I bet you this one here is going to be no solution because I just know the way they write their problems. Okay, and I think I may need more space. Don't save it. Don't save it. File, new. Come over here and write this up. Well, I'm liking what I'm seeing here. They gave us a variable equal to something. Nice. We don't have to start moving things around. 15x plus 3y equals minus 1. Y equals this bundle, which is, I'm going to put a set of parentheses around it because that's one unit. Y is equal to that unit. What I'm going to do is take that unit, plug it in for y in the other equation, and do some algebra. Okay, plus 3 times that bundle. I'm going to multiply by 3. This is negative 15. 3 times negative 5 is negative 15x. 3 times 1 is 3, equals negative 1. I combine my like terms. 15x plus a negative 15x cancels out. We're left with 3 equals negative 1, and that's false. So this is a situation where we did the math correctly. We did it and the variable went away. And if the variable went away, it's one of those oddball cases. It's nowhere near A. But if you generate false, 3 equals negative 1 is not true on this planet. There's no solution if you generate a false. Fantastic, huh? What do you think? What do you think? Well, let's take a look at this. This is... Let's see let me just take a quick look at what we have here. Oh, we got some word problems, Okay, I'm going to do the word problems. In fact, you know what I might do? I'm going to do this solve by substitution and then stop the video here because the word problems tend to require more effort, and so I'm going to do a separate video on the word problems. So let's do this one here, new. So at least after watching this first video, you'll be able to do the first 8 problems. So let's take a look. P plus 2Q, it doesn't matter, P's and Q's, X's and Y's, it's the same process. And then we have Q plus 11 equals 4P. Well, to do substitution, what do you need? You need a variable equal to something, and I'm not seeing a variable equal to something, so we got to get it to equal something. And it doesn't matter which one you use. I could just get rid of a minus 11 on this bottom equation. Subtract 11 so that I get a Q equal to 4P minus 11. And at the very least, I do have a variable equal to something. That something is a bundle. And what I'm going to do is take that bundle, substitute it into the other equation for Q. There you go. And then what we're left with is P. After I do the substitution, I'm copying this. P plus 2 times the bundle, 4P minus 11 equals 14. So I'm going to multiply through the parentheses. The first P is what it is, plus 8P minus 22 equals 14. Combine your like terms. 9P minus 22 equals 14. I'm going to add 22 to both sides. That will give me 9P equals 36. That's a 9, a very ugly 9, but it's a 9. And if I divide by 9, I get P equals 4. Okay, I'm getting a nice whole number, should be correct. And so in this case, when you got P's and Q's, it's not totally, you can't put it in this form because this form is an X and Y form, so you don't know which number goes where. That's why they say, well, if P, they're saying just separate the P's. P is equal to 4, so for sure I'll put the 4 there. Now, what do I get for the Q? Go up here. Q is equal to that bundle, so take the 4, plug it into here. I'm getting 4 times 4 minus 11 is 16 minus 11. Let's do multiplications first. 16 minus 11 is 5. And let's go ahead and put the 5 there. You check your answer. There you go. So I'm going to stop the video here and pick up on problem number 9 in the next video. Okay, take care.